Hello. Today I would like to calculate the following sum. 1 multiplied by 2 plus 2 multiplied by 3 plus 3 multiplied by 4 plus dot 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 plus n multiplied by n plus 1. And this can be written as a sum of I equal 1 to n from I multiplied by I plus 1. In order to calculate it, we will do again the binomial expansion. For I equal 1 to n, we will expand the following binom: I plus 1 squared, and this is equal with I squared plus 2i plus 1 plus I plus 1 squared. And we will have to calculate this sum for all i's from 1 to n. For I equal 1, we have 1 plus 2 squared, it is equal with 1 squared, plus, actually I think that is better if I draw it a little bit down, because it will be the calculation mode will be clear. Okay, and I'm putting it I equal 1. This means 1 plus 2 squared, it is equal with 1 squared plus 2 multiplied by 1 multiplied by 2 plus 2 squared, and this is equal with 3 squared. For I equal 2, we have 2 plus 3 squared, which is equal with 2 squared plus 2 multiplied by 2 multiplied by 3 plus 3 squared, and this is equal with 5 squared. I equal 3, I have 3 plus 4 squared, it is equal 3 squared plus 2 multiplied by 3 multiplied by 4 plus 4 squared, it is equal with 7 squared. And we go like this till I equal n minus 1, and I will have in here n minus 1 plus n minus 1 plus 1, it's n squared, it is equal with n minus 1 squared plus 2 n minus 1 multiplied by n plus n squared, it is equal with 2n minus 1 squared. And last, I equal n, I will have n plus 1 squared, it is equal with n squared plus 2 n plus 1 plus n plus 1 squared, which is equal with 2n plus 1 squared. Now we have to add all these expansions. Nothing will be, how can I say, nothing will be removed, and I will end up with 1 squared plus 2 squared plus 3 squared plus n minus 1 squared plus n squared. This is the sum of the first of the square of the first n numbers. Then we will have 2 multiplied by 1 multiplied by 2 plus 2 multiplied by 3 plus 3 multiplied by 4 plus dot 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 plus n minus 1 multiplied by n plus n multiplied by n plus 1 plus the last term is, and in order to do it I will add in here plus 1 squared and also in here, and I have to subtract it also, of course. So I have in here 1 squared plus 2 squared plus 3 squared plus 4 squared plus n squared, and that's it till here, plus n plus 1 squared minus 1, because I have these two in here, yes, and this is equal with 1 squared plus 3 squared plus 5 squared plus 7 squared plus 2n minus 1 squared plus 2n plus 1 squared. Sorry, I will have to delete it again. So this one, I'll keep it like this, and so it will be like this, plus 2n plus 1 squared minus 1. It is this minus 1, this one in here cancels with this one in here. Okay, so already minus 1 and minus 1 cancels, and we see here that this is the sum that we are trying to calculate. It's S. Okay, now I will go to the next page like this, and I will use the following quantities because I already know them from a previous video. 1 squared plus 2 squared plus 3 squared plus dot dot plus n squared, it is equal with n multiplied by n plus 1 multiplied by 2n plus 1 over 6. And another sum, it is the sum of the squares of the first n odd numbers. It's 1 plus 3 squared plus 5 squared plus 2n minus 1 squared, and this is equal with n multiplied by 4 n squared minus 1 over 3. We will use these two sums. So now I have 2 multiplied by n plus 1, 2n plus 1 over 6, and y2 because they are repeated, plus 2s plus n plus 1 squared. And in here I have the sum of the first n odd numbers, and this is n multiplied by 4n squared minus 1 over 3 plus 2 plus 2n plus 1 squared. And we will start doing the calculations in order to obtain the sum. First step is to expand these two binomes, and we will obtain something like n multiplied by n plus 1 multiplied by 2n plus 1 divided by 3 plus 2s plus n squared plus 2n plus 1, and this is equal with n 4n squared minus 1 over 3 plus 4n squared plus 4n plus 1. Again, 1 is cancelled, and the next step is to transfer these terms to the right and to do these multiplications. And I will have actually something like n multiplied by 2n squared plus n plus 2n plus 1 over 3 plus 2s plus and this is equal with n 4n squared minus 1 over 3 plus 4n squared minus n squared is 3n squared plus 4n minus 2n is 2n, and I will multiply by 3 and by 3 and move this term to the right. And then I see also that the term n it is found in every expression except s, so I can write something like, give me a second, 2n squared plus n plus 2n plus 1 over 3 plus 2s over n, it is equal with 4n squared minus 1 over 3 plus what do we have in here? It's plus 9n squared over 3 plus 6n over 3, and then 2s over n, it is equal with 4n squared minus 1 plus, actually if I extract n, I will have in here this and this, like this. 4n squared minus 1 plus 9n plus 6 minus 2n squared minus 3n minus 1 over 3. 6s over n, it is equal with 2n squared, this one and this one, plus 6n, this one and this one, and plus 4. This one, and this one. Now we can multiply it by 1 over 2, and I will have 3s over n, it is equal with n squared plus 3n plus 2, and I have 3s over n, it is equal with n squared plus 2n plus n plus 2, 3s over n, it is equal with n squared, and without, 1 second, do this like this, okay. So n, it is equal with n multiplied by n plus 2 plus n plus 2, so 3s over n, it is equal with n plus 2 multiplied by n plus 1, and I have finally s, it is equal with n multiplied by n plus 1 multiplied by n plus 2 divided by 3. So in conclusion, 1 multiplied by 3, 1 multiplied by 2 plus 2 multiplied by 3 plus 3 multiplied by 4 plus 4 multiplied by 5 plus ... plus n multiplied by n plus 1, it is equal with n multiplied by n plus 1 multiplied by n plus 2 over 3. Thank you for listening.